Hello guys, my name is Prince and this is Smart Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic mensuration. In the previous video, we learned how to find the area and perimeter of a rhombus. In this video, we are going to learn how to find the area and perimeter of a kite. A kite is a four-sided plane figure, so it's another example of a quadrilateral. So the figure we have here, A, B, C, D, is an example of a kite. Two pairs of adjacent sides are equal, and the diagonals bisect each other at 90 degrees. So for this kite, the side BC and the side DC are adjacent to each other and they are equal. So the length BC is equal to the length DC. The same way, the length AD and the length AB are also equal. So BC is equal to DC and AD is equal to AB. The diagonals also bisect each other at 90 degrees. So the diagonal BD will bisect the diagonal AC at 90 degrees. What that means is that this diagonal here, which is AC, will divide BD into two equal parts. So the diagonal BD will be divided into two equal parts by the diagonal AC, and they meet at 90 degrees. So the angle here is 90 degrees. Okay. Now, how do we find the area and perimeter of a kite? The perimeter, as we've been learning, is the total distance around a figure. So here is going to be the length AB plus the length BC plus the length CD plus the length DA. The area is equal to half times the product of the diagonals. So here is going to be half times the length AC times the length BD. Let's use this to solve some questions. Find the area and perimeter of the kite below. So we have been given this kite. We have SR to be 7 centimeters, PT to be 3 centimeters, ST to be 2 centimeters. Okay, considering this kite, we have just learned that the diagonals meet at 90 degrees. So it means that the angle here is going to be 90 degrees. We also learned that this diagonal PR will divide the diagonal SQ into two equal parts. So if from S to T is 2 centimeters, then it means that from T to Q is also 2 centimeters. So now we have the length of this diagonal, which is SQ, because it's going to be 2 centimeters plus 2 centimeters. Remember that the area of a kite is half times the product of the diagonals. So we have one diagonal, we have to look for the other one. The other diagonal is PR. We have PT as 3 centimeters. So it means that we need the length TR. If you consider the point STR, you will see clearly that it forms a right-angled triangle with ST as 2 centimeters, SR as the hypotenuse giving us 7 centimeters, and we are looking for TR. So we are going to apply the Pythagoras theorem here. If you apply the Pythagoras theorem, you will see that SR squared is equal to ST squared plus TR squared. So you have 7 squared is equal to 2 squared plus TR squared. You simplify everything and you find TR, you are going to get 6.7 centimeters. So it means that from T to R is 6.7 centimeters. So now we have the diagonal PR, we have the diagonal SQ, so we can find the area of this kite. Okay, so SQ and PR are the diagonals. SQ is equal to 2 centimeters plus 2 centimeters, as you can see here, and that will give us 4 centimeters. PR will give us 3 centimeters plus 6.7 centimeters, and that will give us 9.7 centimeters. So we have these two diagonals. The area of a kite is equal to half times the product of the diagonals. So it's equal to half times 4 centimeters times 9.7 centimeters, and this will give us 19.4 centimeters squared. So this is the area of this kite. Let's move on to the perimeter of the kite. So the area of the kite is 19.4 centimeters squared. The perimeter of the kite. We know that the perimeter is the total distance around the figure. We have SR as 7 centimeters. We learned that for kites, for this particular kite here, the length SR will be equal to the length QR. So if SR is 7 centimeters, then QR is also 7 centimeters. In the same way, the length PS is equal to the length PQ, since we learned that for kites, adjacent sides are equal. So PS is equal to PQ. So it means that if you're able to find PS is the same as PQ. If you consider the point PTS, you see that it also forms another right-angled triangle with PT as 3 centimeters and TS as 2 centimeters. So if we apply the Pythagoras theorem here, we can find PS. If we are applying the Pythagoras theorem, we will have PS squared is equal to PT squared plus TS squared. So PS squared is equal to 3 squared plus 2 squared. You simplify this and PS is equal to 3.6 centimeters. What that means is that from P to S is 3.6 centimeters. But since PQ is equal to PS, PQ is also 3.6 centimeters. So if you consider the kite now, we have SR, we have RQ, we have PQ, and we have PS. So we can find the perimeter. The perimeter of this kite here is going to be the length of PS plus the length of SR plus the length of RQ plus the length of QP or PQ. That will give us 3.6 centimeters plus 7 centimeters plus 7 centimeters plus 3.6 centimeters. You add everything and we are going to get 21.2 centimeters. So the perimeter of this kite here is 21.2 centimeters. Thank you for watching this video. Don't forget to subscribe to this channel for more videos. So far, we've considered how to find the area and perimeter of 6 quadrilaterals. We've learned how to find the area and perimeter of a rectangle, a square, a rhombus, a parallelogram, a trapezium, and a kite. In the next video, we are going to learn how to find the area and perimeter or circumference of a circle. So we are going to concentrate on a circle in our next video. Bye bye.